Hi, my name is Jackson Bruce, and I'm a junior studying electrical engineering at the FAMU FSU College of Engineering. I am an intern at the Center for Advanced Power Systems. Something that I recently experimented on is finding the critical current for high-temperature superconductors. A superconductor is a material that has no electrical resistance as long as it is in the superconducting region. This region is governed by the current, the temperature, and the magnetic field of the superconductor. The bounds of this region is determined by the critical current, critical temperature, and critical magnetic field. If it goes past these bounds, the superconductor starts to have resistance, and then it is not a superconductor anymore. In the experiment, I am measuring the critical current of high-temperature superconductors. High-temperature superconductors are being developed to be used in electrical aircrafts and ships. This is because it has a significant space and weight reduction. But in order for this to be implemented, it needs to have a current flow of several kiloamps and power ratings in the megawatt range. The tools I used were a shunt resistor, voltage taps, ramp generator, current power supply, high-temperature superconducting tape, and a National Instruments data acquisition card. The National Instruments data acquisition measures both the current from the current power supply and the voltage across the high-temperature superconducting tape. Since the National Instruments acquisition can only measure voltage, the shunt resistor was used. The shunt resistor has a known resistance, and by using Ohm's law, we can find the current using the known resistance and the voltage measured across the shunt resistor. High-temperature superconductors have a critical temperature of 90 to 110 Kelvin. During the experiment, the high-temperature superconducting tape was submerged in liquid nitrogen to keep the temperature at 77 Kelvin, which keeps it in the superconducting range. We ran current through the high-temperature superconducting tape, increasing it every few seconds until we started seeing voltage across the superconductor. LabVIEW was used to collect the measurement data. The critical current for the high-temperature superconducting tape was measured at 110 Kelvin. The skills I learned from this experience was how to use LabVIEW and the National Instruments data acquisition equipment, and I also learned more about superconductors. I would like to thank the FAMU FSU College of Engineering, the Asterisk program, Dr. Pamiti, Dr. Cheatham, and the Center for Advanced Power Systems for this experience and all the things they taught me. I would also like to thank my mentor, Paul Mensah, for all the help he has given me. Thank you.